I want to go over a few more examples in our notes that we started today in class. So go ahead and turn to function notation in your notes, and then you'll see where we left off. So this is what it looks like. We talked about that in class, but I want you to go down to, we're going to do numbers 9, 11, and 12 together to make sure that you understand it. All right, so let's take a look at this. This before is really y equals 2x squared plus 4x minus 9. So this is a function notation is just a fancy way to say all this represents my value of y. Okay? So here's my function. And remember, we are evaluating this function now when x is negative 8. So my x value is negative 8, so I'm going to plug in negative 8 here, and I get 2 times negative 8 squared plus 4 times negative 8 minus 9. So I'm evaluating this function when x is negative 8. Okay? And we talked about that in class. So this is 64 times 2 minus 32 minus 9. So 128 minus 32 minus 9 is 128 minus 41. And then I get as my answer, it's going to be 87. Okay, so 87 would be my answer here if I evaluated this function when x equals negative 8. And then I could do the same thing and evaluate this function for part, if I'm looking for b, then I would evaluate this function when x equals negative 5. So I can rewrite it, I guess. So 2 times negative 5 squared plus 4 times negative 5 minus 9. And I get 2 times 25 minus 20 minus 9. 50 minus 20 is 30 minus 9, and I would get 21 as my answer. So when x is negative 5 is my input, my output is 21. So when x is negative 5, y is 21. And I can even write that as an ordered pair, 5 and 21. And up here, when x was negative 8, I got y was 87. So that's another representation you can look at, because we've seen that before. When x is negative 8, y is 87. When x is negative 5, y is 21. And again, I could do it when x is negative 2. So I can evaluate this function when x is negative 2. And I get 2 times 4 minus 8 minus 9. So 8 minus 8 minus 9 is negative 9. So when x is negative 2, my y value is negative 9. You have an input, spits out an output. Okay? Function notation. So if I look here in a word problem, we see that anthropologists use the length of certain bones of human skeletons to estimate the height of the living person. I think that's pretty cool. One of these bones is the femur. To estimate the height in centimeters of a female with the femur length of x, the function h of x equals 61.41 plus 2.32x can be used. So that's a formula. So remember our Brian example with the hot dogs in class today, we got that rule. So this is the rule that's being established to estimate the height of a female with a femur length. So when they dig up the bones, now we have, they found the femur length was 46. Okay, so 46 was the length of the femur. So I'm going to plug it in here to find out the height of that female. So when I plug in 46, I get 61.41 plus 2.32 times 46. And I'm going to let the magic of my notes answer this question. And I'm getting 168.13. So the female, and this is in centimeters, right? That's in centimeters. So the female is 168.13 centimeters. And then, of course, we could transfer that to meters and look at it that way. Okay, so again, we're evaluating when x is 46 and it's spitting out that output. So when x is 46, my output is 168.13 if I wanted to look at that as a set of ordered pairs. X is this, y is this. All right, so I said we were going to go over number 12 today in class. So I want you to look at it in the form of a graph. Well, remember, this is really just a fancy way of an ordered pair. So it's asking us, When x is -4, what's my output? When x is 0, what's my output? When x is 2, what's my output? When x is 5, what's my output? Well, this is the easiest way to do because it's a graph. So I'm going to look at my graph and let the graph work for me. So I'm going to go over, well, when x is -4, 1, 2, 3, -4, what's my y value? 2. So this is just a plotted point. -4, my y value equals 2. So I fill it in. When x is 0, where's my graph at y? It's at 0. So it takes the origin. When x is 2, where's my graph? At -2. When x is 5, what's my y value? -1. So you'll see these points, because those lie on the graph, and these points, I can put -4, 2. This point here is 0, 0. This point here is 2, -2. And this point here is 5, -1. So when my input's -4, my output is 2. When my input is 0, my output is 0. When my input is 2, my output is -2. When my input is 5, my output is -1. So it's kind of easier to read it on a graph because you're just looking at the picture and then putting it as a set of ordered pairs. So if this does not make sense, come and see me before Thursday. Thursday is the last day I'm going to be able to help you because we have rockets on Wednesday. So hopefully this makes sense and you can complete your homework. If not, see you in tutorials.